and welcome to my talk, An Introduction to Mutation Testing, or Why Coverage Sucks. A quick agenda for today. We'll start with a self-introduction, the motivation for this talk, then see what is code coverage and the problems of code coverage, see then what is mutation testing, an example of a framework for Java, PIT, how we are using mutation testing at Fidzai, and some final remarks. So who am I? Pedro Rijo, as I said. I've been working as a Java and Scala backend developer. You can find me on my Twitter handle, pedrorijo91, or on my personal blog, pedrorijo.com. And a quick background. I finished my master's on Técnico Lisboa on 2014. I then worked for 1 year at Phoenix Edu, academic management learning system. Then I spent 2 years at Codacy, a Lisbon startup with a static analysis platform. And since 2017, I've been working at Fidzai. And what is Fidzai? Fidzai is a fraud detection platform. So we basically catch the bad guys on e-commerce frauds. And we use state-of-the-art artificial intelligence and machine learning. So yes, we do use neural networks and deep learning. Our platform consists in real-time processing of transactions and is used by some of the biggest banks, payment processors, and retailers across the globe. Example of a few of our clients, we have Citibank, Cuscal, Lloyds, Co-op, Leumi Card, and Credorax. We have a lot more, but a few examples. So this means that basically, if you had your credit card decline, maybe it's our fault. And just to give you an idea about our platform needs to be up 24/7, every day, every hour, because e-commerce never stops. And we use typical replication strategies across multiple data centers, and obviously we need to have a no downtime deployment. Due to all of these requirements, we know and we care about code quality and automated testing because we know it helps us decrease the number of bugs that we ship into production. And how do we ensure high quality on our platform? So we know that bugs may cause serious problems, both to our clients and to us. So to our clients, imagine if you are an e-commerce site and you are using Fidzai as an anti-fraud system. If during the Black Friday your anti-fraud system goes down, this may imply millions of loss to your company. And to Fidzai, because we have strict SLAs, that if they are not satisfied, mean a lot of fines for us. So basically, this means that all our code has unit tests, both back-end and front-end code. We also have a lot of integration tests that we use Selenium for that. And we also have many system tests that we use with Docker. And we even have a failure module so that we know if some component of our system goes down, what will happen. If one Cassandra node goes down, will our system still be responsive? If one of our servers goes down, what happens? Is going to be 100% okay? It's going to be in a degraded state? So yeah, we have that failure model. You can learn a little bit about that on this link. We have a blog post on that on our company. As most of the industry nowadays, we run our tests before merging our codes. But yeah, we have a few longer builds that we cannot run because they took too much time, and these are typically builds that use different tech stacks. For instance, we have clients that want our system using Cassandra, others want our system using Postgres, others MongoDB, and so on. Some of them want RabbitMQ, ActiveMQ. They have Spark installed in different ways. So yeah, these builds typically run during the night or the weekend. And with all of this, we start wondering, okay, are we spending too much time testing? How much testing are we doing? Are we wasting time? with bringing little value for more tests. And yeah, even for TDD adopters, not even TDD can answer these questions. So this is where code coverage comes into play. Code coverage is the measurement of the amount of lines, the percentage of lines that are run during your test suite. There are some subtle variations. You can have line coverage, statement coverage, branch coverage, method coverage, and a bunch of other coverage types that you can see on the Wikipedia, because most of them I don't know even. But even that doesn't guarantee that, even code coverage doesn't guarantee that our code is bug-free, because code coverage is not silver bullet. We're going to see a few examples. For instance, imagine we have this function on our code that checks if a number is bigger or equal than 10. Nothing special, and we have our test, and we check what's the output for given the argument 11 and argument 9. Okay, and now we are pretty satisfied because we're going to see the code coverage report, and we have 100% code coverage for these methods. But we can see that if x is equal to 10, we are not testing that value. It's a boundary value that if someone goes there and changes the value, your tests are not going to detect. So, okay, we are going to add another test that's going to use the 10 value. And now we are doing, for this method, testing with 11, with 10, and with 9. And this should be enough to give you some confidence that your tests are good. But even if code coverage reports 100%, you forgot to do the assertions. And this may seem that it's a bit silly, but especially depending on the assertion library that we are using. For instance, FeedSci, sometimes we use in Java the AssertJ library that has a concept that is soft assertions, especially useful for testing complex data structures or collections that you basically do the assertions, but only at the end you need to call the method to check and if applied to fail the test. This actually happened 1 or 2 months ago on our code base during a pull request. Someone forgot to do the final assertion. So he had a bunch of assertions, but they are not doing anything because they are not being actually called. So, and this is where mutation testing can be very useful. And what is mutation testing? Well, in case you are maybe thinking that, it has nothing to do with Wolverine or X-Men. It's another way to check the strength of our tests, alternative to code coverage, because we have seen that code coverage is not as reliable as we thought. This is an old idea introduced by Richard Limpton in 1971. And the basic idea is to introduce subtle small bugs on our code base and check if the test suite is able to catch them. Some of you may be thinking, well, is this something to be used or not? And we kind of have that already with Netflix Chaos Monkey that brings down some parts of your service and of your system and detects if what's the response, if it's what we are expecting or not. So it's not a completely new idea. Example for mutation testing, what may happen. So we have this method, detects if someone is old enough, given a certain age. So it checks if it's bigger as greater than or equal to 18. And mutation testing will generate a different version that can be, for instance, it checks if age is bigger than 18. Notice that we no longer have the equal sign. And mutation testing is based on the competent programmer hypothesis. It simulates easy bugs because it assumes that overall the programmer is competent and the program is almost completely right. There are only some small changes that make the program not 100% correct. As a recommendation, this mutation testing should also be included on the development life cycles, just as you have your other unit tests. It can be run afterwards or during. And okay, going into a few basic mutation testing concepts. Okay, we have mutation operators or mutators that are basically the operations that change your codes. We have, as an instance, what we saw. We are replacing the bigger than sign for smaller than. You can be replacing the OR operator with the AND operator and many more operators. Then we have mutants. Mutants are the modified version of your codes. After basically your code after applying the mutant operator. Then you have mutations that can be killed or survived. So you have your modified version of your codes, you run your unit tests with that modified version, and if your tests start failing after the modification, it's because they detected that a change was introduced and we say the mutation was killed. And this is the goal, to fail tests when we change codes. And on the other side, we have the survived mutations. When you change when mutation testing changes your code, if your tests are not failing, then something is happening. Because it should be failing. Your tests are not as good as you think. And then we have the equivalent mutations concept. This is a little bit more tricky, but nothing special. Basically, you can create operations, mutations, that will not change your system behavior. This is very frequent, for instance, when we have dead code around your platform. During your refactor, you forgot to delete something that is not used anymore. Yeah, mutation testing can change that code, but doesn't matter for you. A simple example also. We initialize a variable S2. We check if that variable is bigger or greater than 1, and if yes, we return foo. The mutant version could be, for instance, replacing the greater than or equal with the greater than 1. This will not make your tests fail because it's impossible, or you are initializing the variable to 2. And maybe this example seems silly, but in an older code base, during refactors, you could have, on the initial version, a variable being passed to multiple functions that would mutate the value, change the value, and not anymore because, yeah, you changed your code. And this is very easy to happen when you have nested function calls. So equivalent mutations, when do they happen? On dead users' codes, on code that only affects performance. For instance, you have a cache if the cache is empty, you're going to calculate something. Yeah, if you mutate the code that goes to the cache, it will just go compute again the value, so your test won't fail, but yeah. Mutations that can't be triggered due to logic elsewhere on your program, like we see before, and mutations that only change the internal state of your program. A few more examples of mutation testing. This is similar to the one that we have seen before. We have just a function that returns if the value given is bigger than 10. And a possible mutation would be to change to x different than 10. Another example, a little bit different, you have the function that adds 1 to the given x, and now it subtracts 1. Yet another example, we have a function that maybe it's generating a new object that you need on your logic, and mutation testing will change this function to return simply null. Yet, the final example, a little bit more logic. Inside the if, you are checking if the given string is equals to something, to random, and if yes, returns 0, otherwise it returns 1. Another possible change is to simply return the if condition to true always. So it will always return 0. If you don't have any test that checks for 1, it will fail. Now digging into a specific mutation testing framework in Java, Pit. This is their logotype with the website pytest.org in case you are interested. And what about Pit? Pit is very easy to use, partially due to Maven support. For those that are not aware, Maven is probably the most used build tool in Java. It's also very efficient. contrary to other mutation testing frameworks for Java. Unfortunately, it doesn't support multi-Maven projects, but there's a plugin that you can add, and it's very easy, and we will have support for multi-Maven models projects. So if you want to start with mutation testing in Java, you simply add this Maven plugin on your POM file. 5 lines, very easy. If you are using the multi-Maven model plugin, you just need to add the other plugin, also very easy. And then, if you just need to run this Maven target or PyTest Maven mutation coverage, or if you are using the multi-Maven model plugin, this command. Very quick, very easy. This will generate a report under target/pit reports and the date. Not sure if you can see properly the example of the report, but you have the blank lines that are not relevant, method signature, comments, and so on. We have the light green lines that is code that the mutation testing framework did not choose to change, whether it's because your configurations or because it's not very interesting. You have the stronger green lines, lines where a mutation was generated but was caught by your test, so the mutation was killed. We have the light red/pink line that are lines that do not have coverage, test coverage, so during your test suite run, they never were processed. And finally, you have the darker red lines that were lines where a mutation was generated, but it was not caught by your tests. The mutation survived. You can see, I hope you can see, on the bottom, we have some mutations. 2 mutations, for instance, on line 83 and 90 were negating the conditional on the if clause, and your tests killed those mutations. Another example on line 100, the return value was replaced by null, basically. And yes, it was also killed, so your test suite caught this. And then you have 2 mutations that were not killed by your test suite. The first one was a negated conditional on line 116 and 117. It was replaced by null and was also not caught. Finally, you still have on the bottom the last 3 lines mutations that were generated, but there are no tests passing that line, so we cannot infer anything about that. So what more about Pit? As any proper build plugin, it allows you to configure when to fail a build. You can have a mutation score threshold, very similar to a code coverage percentage. And you probably may need, at least at FeedSci, we felt the need to skip some methods because we don't really care about testing the toString method, the equals method, and the hash codes. In your case, you may even need to skip full classes or test classes. And how do we add added mutation testing to FeedSci code base? So we're starting a proof of concept using a smaller repo. This repo is the OpenML, a new project that we started last year to integrate any machine learning library into our platform. I have the links for the tuple requests that I did as a POC. The first one adding the configuration, the second one adding the fixes proposed by the mutation testing. And now we are trying to integrate in some internal libs before making into our main repository. So it's an example of the configuration that we are using on that OpenML repository. I think it's kind of small. Adding the plugin now on the configuration, I'm skipping one of the Maven models because it's just an example. I'm saying that I want to use all the mutators. Python has a lot of mutators. Some are default, others are not because I'm not that, still a bit experimental. I'm excluding the methods, as I said, the toString, hash code, equals, specifying the threshold to 75. I'm specifying multi-threading, nothing special here, kind of obvious everything. And what have we got with the mutation testing on this repository? We found some redundant logic on our code, and also some missing test case for boundary values or null checks, so on. On the pull request that we did with the fixes, we can see we introduced almost 600 lines. Only a few of them were actually on the code itself. The others were on tests, adding more test cases and so on. And we removed 70 lines from redundant logic. On this example, we can see where we forgot the null check. On this example, we forgot one of test scenarios with and we created a parameterized test. I don't know if you are familiar with it, but parameterized tests allow you to run your test suite or test class with a small variation on the parameter, as it was on this case. This is the redundant code that we found and removed. And these are the more obvious cases on this small project that we started, mutation testing. So can we add mutation testing everywhere? Until now, we can't say that we can't add everywhere. We have been with a small struggle with more legacy code, and especially on unit tests not so well designed. If you are creating an H2 database, you have to be a little bit more careful, because if you are mutating the connection to the database, it will fail your tests for other reasons that not your logic. And some common complaints when using mutation testing, if you Google around. First, the equivalent mutations may be a problem. It depends on your framework, if it generates a lot or not. A lot of people complain that mutation testing is slow, and it depends a lot on the mutation testing framework. For instance, in Java, the naive way would be to change the code, compile the code, and run all the test suite. This is kind of inefficient, and Pete manipulates the bytecode, so it skips the compilation phase, and uses coverage info to check, okay, for this mutation, which test do I need to run? I don't need to run all the test suite. Some data, so to have an idea, for Apache Commons Mat, that a project that has Java project with something like 100K lines of code and 100K lines of test codes. It takes 8 minutes to compile or run the tests, and to run Pit without any specific configuration, it takes around 1 hour. This can be tuned to avoid some classes and so on. And there is also another feature, incremental analysis, that uses information from previous runs to run everything again. Other people complain about mocks, but Pit, at least, I don't have any complaints on tests with mocks. It supports JMock, EasyMock, Mockit, PowerMock, JMock, almost all mocking libraries for Java. And if you want to make it even faster, you can use extreme mutation. The idea behind extreme mutation is to replace all the logic on your methods by an empty statement, let's say. So if your method returns an integer, it's going to replace all the logic by return 0. If it returns a string, it will return an empty string. If it returns a collection, it's going to return the empty collection, and so on. It's good to some preliminary analysis, so you have some idea. But personally, I haven't tested yet. But if someone is interested, there's a plugin, another engine, let's say, the PyTest test cards, that allows you to do that. Example of extreme mutation, we have a method that does a bunch of stuff. It gets a string and checks stuff, adds more to the string. And in the end, it returns an optional of the mutated string. And with mutation test, with extreme mutation, this could be replaced simply by return optional empty. And the idea then is the same that usual Pit mutation testing. It's to check if the tests fail or not. This generates a lot less mutants, because you don't have so many possibilities. And it's way faster. I think some data that they have, some kind of benchmarks, it was kind of 1/10 of the time. So for instance, for Apache Commons Math, let's say instead of taking 1 hour, maybe it will take just 10 minutes. That's not that bad, it's pretty good actually. So, conclusion. We all know that keeping a code base free of bugs, it's not an easy task. And we also need to know the strength of our tests to know, do we need to do more tests or not? And we have seen that covers us a few fundamental flaws, and mutation testing is a better metric. Unfortunately, it's a bit more heavy computationally, but seems the right path, and some performance optimizations are making it very usable. I know that the eVote system from Norway uses mutation testing, so yeah, it's being used elsewhere, not just academic. A few links that you may see afterwards. I wrote a small blog post, Introduction to Mutation Testing, where I dig a little bit more than this talk. And if you want to test mutation testing on other languages, you have a framework for Ruby, for JavaScript, for Scala, for C#. I never tried those, but from what I saw, they seem to work and people are happy with it. So if you want to learn more about what we are doing at Feedzai, check our tech blog on the bottom or our careers page, and yeah, we are hiring. Any questions?
You said that these tests are a bit slow. Do you run them periodically, like you do with some Selenium tests, or do you
for mutation
run them
testing?
in Jenkins?
Yeah, for mutation testing, we are run on each pull request on Travis, because first we are using small projects, so it's not a problem yet. And as I said before, we can tune the mutation testing to skip some classes, some methods. You can limit the used mutants. You can limit the number of mutants that are being generated for each class. So you can tune a lot to make it faster. And yes, you can use extreme mutation if that's a problem.
Okay, thank you.
Hi. I was wondering how you integrated this into like the development, because it seems like you started ignoring code coverage metrics and just cared about like mutation testing when you make a pull request.
Yeah, we still are using code coverage, and we started integrating mutation testing. But as I said, we are still experimenting and trying to make it solid so we can have our whole code base with mutation testing. And as I said, it's being used on each pull request on the Travis. So every time we do the pull request, we run the mutation testing.
Thank you, Pedro, for the awesome talk you gave us today. I was wondering if you could talk a little more into detail about how do you document this procedure? Do you just go to the code base and open a class randomly and just let's mutate test this, or do you use user stories or something like that will guide your tests?
I'm not fully understanding your question. You are asking how do we start the process of...
Yeah, how do you decide which classes or which blocks of code are you going to make mutation testing? Are you based on user stories or something like that when you're building tests, for instance?
So we run the mutation testing framework that mutates everything, basically, unless you say not to mutate some classes. So we do not choose classes to mutate unless you are having performance problems and you want to limit to some.
Okay, thanks.
Was that the question?
Yes,
okay.
Sorry.
Hi, good afternoon. It's just a small question. Usually when we start a development, everyone starts to look at the time that we need to to finish the development, and the first thing to kill is always the tests. And we look at the tests in different phases and different types of tests in all the phases, like unit tests, integration tests, functional tests, using also Gherkin to define other BDD tests. And we have a lot of options to decide. The problem is some of the options override other options. And we need to make sure that we do the right decisions when we need to do the stuff in less time. And my question is, do you think if this mutation tests is something that can replace other kind of tests, or is something that we need to add to the pile of other tests to do?
So you don't do mutation testing, you use mutation testing to check your tests, like you do with coverage. Not know if you use coverage, but most of the companies use coverage to check if they have enough tests or not. Mutation testing is the same, but it's a more reliable metric. Yeah, if your company starts to cut on tests, mutation testing will say, yes, you do not have enough tests. But now it depends on the company to allocate some time to do the tests.
I'm not sure if you already addressed this because I only came in the middle, but do you think this applies to all the types of code, or for example, code with a lot of side effects is not good to be tested with this? What's your feeling? You talked a bit about the databases part, that you had some problems. Do you think overall side effects are a problem, or?
I don't. It depends, because if your unit tests have side effects contained and they are not doing anything very dangerous, there's no problem. But if you have side effects like accessing that database or HTTP requests, that's one of the problems of mutation testing, that it doesn't deal very well with not so well designed unit tests. So yeah, it can be a problem, but more questions?
Hi, thanks for your great presentation on great theme. I don't know if you can answer me this question, but have you tried messing around with Striker and JavaScript mutation testing?
Not yet, to be honest. Yeah, I saw that this seems to be a project that's very active, and I saw people liking the project, but I never tried, so I don't know which problems it will bring.
It's slow.
It's slow?
Yeah. I just wanted to know if you found any strategies to mitigate them.
I don't know if Striker allows you to tune, to specify, to limit the tests.
Incremental, yeah. It
can you have incremental analysis also?
Yeah.
Okay, so it should be a good help, no?
It is. It makes them at least feasible, or else we're talking about hours for small code bases.
Okay.
So yeah.
Okay, yeah.
I just wanted to know if you had another approach, because I don't know many companies that do this. We are trying to implement mutation testing on some of our projects, but we have a huge JavaScript stack as well, and we are finding a lot of problems with that. We're still doing it. I mean, they're not extreme problems that would change our decision to go with mutation testing, but we need to find other ways to avoid them.
Yeah, I was trying to make mutation testing stable on our backend code base, and then try to propagate to other parts like the front end. And
yeah, that's a good idea, because we started the other way around. Thank you.
Yeah, and it didn't go well. Okay, thank you.
Hi again. I was wondering, from your experiments, how effective the mutation testing was in terms of the number of failures per commit.
Number of?
Failures. So how many times mutation testing discovered missing test assertions and stuff like that, versus like running the integration tests or running the system tests So, because typically the unit tests fail less than the other ones, so I was wondering how worth it was.
So, about failed, forgotten assertions, for instance, we never had that problem on those projects that started using mutation testing. But discovering missing boundaries, we had on that project that I spoke, OpenML, that is not the project that is having pull requests every day. But I think in the last 2 months, we had like 5 or 6 pull requests, and 2 of them, the mutation testing found some stuff that was missing on the test, some check. But yeah, it's a small project, so it doesn't have a huge amount of logic. It's quite simple, but even so, it found on 2 pull requests some missing cases.
So, hi. Not really a question about the presentation, but your experience with equivalent mutants. Did you find some on your code? How you dealt with them?
Yeah, from my experience, equivalent mutations sometimes are not very easy to understand on the report, but as I showed on one of the slides, we found one equivalent mutation that was logic that was kind of duplicated, so we refactored. But as I said, I can't say that we had many equivalent mutations. Maybe because the project is new and hasn't suffered a lot of refactors, but I imagine that in older code bases with a lot of refactors, there may be more redundant code or dead code. So, but yeah, from my experience on this, I can say it's a big problem. It was not a pain yet.
Just one simple question. Do you think that there is so much value added on including mutation testing on every commit that you can really do without it? Or do you think that you can do it, or you could do it like on a periodical basis and just getting a report on your test quality so that you don't have to incur the computational overhead?
From my personal experience, when you do periodically and you accumulate a lot of errors on the report, no one's going to look at it. So that's why I think it's more valuable to keep it on the development life cycle itself. But if your company has a discipline to run every week and then go and create Jira tasks so someone can pick it up on next week, maybe that's good enough, yeah. There's no more questions. This is the final call. At FeedZai, we have some scratches for you on our booth. So come, see us, talk with us, and you may win a Nozzle Life ticket. Thank you.